Space is the last great frontier, a cosmic ocean filled with wonders so strange they make even the wildest science fiction seem tame. Out there, drifting among the stars, are objects that defy logic, things so bizarre they leave astronomers scratching their heads and rewriting textbooks. Imagine a planet where it rains glass sideways, or a dying star that pulses like a cosmic lighthouse with the precision of an atomic clock. These aren't plot twists from a movie, they're real, documented phenomena hiding in the depths of the universe, waiting to be uncovered. Think about the night sky for a moment, how serene it looks, how familiar, but peel back that quiet curtain and you'll find a reality far stranger than anyone could have dreamed. Black holes that spin at nearly the speed of light, ancient stars older than the universe itself, and mysterious radio bursts that repeat like signals from some distant intelligence. These aren't just quirks of nature, they're cosmic puzzles begging to be solved. And today, we're diving headfirst into the 25 strangest objects ever discovered in space. Celestial oddities so incredible, they'll make you question everything you thought you knew about the cosmos. This isn't just a list, it's a journey to the edges of understanding where the laws of physics bend and reality gets weird. Some of these objects shouldn't exist. Others challenge the very foundation of what we know, but that's the thrill of space exploration. Every discovery peels back another layer of mystery, revealing just how little we truly understand. So buckle up, by the time we're done, you'll never look at the night sky the same way again. The universe is stranger, wilder, and more astonishing than we ever imagined, and we're just getting started. High above our planet, hidden in the vast darkness of space, something unexpected lurks, an enigma wrapped in metal and mystery. The Black Knight satellite isn't just another piece of space debris, it's the centerpiece of one of the most enduring cosmic conspiracy theories of all time. First detected in the late 1950s, this strange object sparked a frenzy among amateur radio operators who claimed it was transmitting bizarre, artificial signals, like a ghostly SOS from the void. Some even swore it wasn't human-made at all, but an ancient alien probe, silently watching us for thousands of years. The legend grew wilder with time. Conspiracy theorists pointed to grainy NASA photographs, insisting the agency was hiding evidence of the Black Knight's true origins. Stories circulated that it predated human spaceflight, orbiting Earth long before Sputnik took to the skies. Even famed inventor Nikola Tesla got tangled in the myth. Some say he intercepted its signals as early as 1899, mistaking them for attempts at extraterrestrial contact. But here's where the story twists. Scientists and historians have repeatedly debunked the Black Knight's alien pedigree. Most evidence suggests it's just a thermal blanket lost during a spacewalk, or perhaps a discarded piece of a satellite tumbling aimlessly through orbit. Yet, despite NASA explanations, the mystery refuses to die. Why? Because space, at its core, is a breeding ground for the unknown. We want to believe there's something out there, something watching, waiting, defying explanation. The Black Knight taps into that primal curiosity, a modern-day myth woven from static-filled whispers and shadowy photographs, and that's the real magic of this cosmic oddity. Whether it's space junk or something far stranger, the Black Knight reminds us that the universe loves a good mystery. Even in the age of satellites and telescopes, some shadows still flicker just beyond our reach. Take yourself back to August 15, 1977, a quiet night at Ohio State University's Big Ear radio telescope. Astronomer Jerry Amon was sifting through pages of data when his eyes locked onto a string of numbers and letters so startling he scrawled "Wow" in red ink beside them. That single word would immortalize the most tantalizing radio signal ever detected, a 72-second burst of noise so powerful, so unnervingly artificial, it seemed to scream, "We are here," from the depths of space. The signal came from the direction of the Sagittarius constellation, blasting at a frequency scientists had long theorized aliens might use, 1420 MHz, a silent channel where cosmic noise is minimal. What made it extraordinary wasn't just its strength, 30 times louder than background radiation, but its narrow-band precision. Natural cosmic phenomena like quasars or pulsars don't broadcast like that. This was a laser beam of sound hitting Earth with the precision of a deliberate transmission. Yet the real mystery, it never repeated, despite dozens of follow-up scans. The wow signal vanished as suddenly as it appeared, leaving behind a trail of theories. Some researchers argue it was a comet's hydrogen cloud reflecting sunlight, others a military satellite test gone unrecorded. But the most haunting possibility lingers. What if it was extraterrestrial, a fleeting hello from a civilization far older than ours, their message lost in the cosmic static before we could reply? Decades later, the debate still simmers. Modern telescopes like the SETI Institute's Allen Array scan the same patch of sky, hoping for an echo. But perhaps the signal's true legacy isn't in solving the puzzle, it's in the way it crystallizes our cosmic loneliness. For 72 seconds, the universe whispered, we just weren't ready to answer. In October 2017, astronomers spotted something hurtling through our solar system that didn't belong, a cosmic stranger with no return ticket. Named Oumuamua, Hawaiian for scout, it was the first interstellar object ever detected passing through our neighborhood. But this wasn't just any space rock. Its bizarre traits ignited a firestorm of speculation, debate, and even whispers of something unnatural. First, there was its shape. Unlike the lumpy asteroids we're used to, Oumuamua was long and thin. Some estimates suggested it stretched up to 800 meters while being only 80 meters wide, like a celestial cigar tumbling end over end. No natural object in our solar system looks like that. Then came the real head-scratcher. As it zoomed away from the sun, it sped up unexpectedly, as if nudged by an invisible force. Comets do this when their ices vaporize, creating a tail, but Oumuamua had no tail, no visible outgassing, nothing to explain its sudden acceleration. Scientists scrambled for answers. Some proposed it was a rare hydrogen iceberg, a chunk of frozen hydrogen gas evaporating in sunlight, leaving no trace. Others suggested it might be a fragment of a shredded planet, ejected from another star system eons ago. But the most provocative theory came from Harvard astronomer Avi Loeb, who dared to ask, what if it's not natural? Could Oumuamua be alien technology, a discarded solar sail, or a derelict probe? The idea wasn't entirely fringe. Its acceleration matched how a thin, reflective object might behave when pushed by starlight. Yet the truth remains maddeningly out of reach. By the time we noticed Oumuamua, it was already racing out of sight, leaving behind blurry images and a trail of unanswered questions. Was it a bizarre fluke of nature or something more? We may never know, but its fleeting visit taught us one thing. The universe is capable of throwing curveballs we're not even close to understanding. And if Oumuamua was a scout, what or who might follow? Deep in the constellation Cygnus, a star behaves like no other, flickering unpredictably, as if something colossal is passing in front of it. Meet KIC 8462852, better known as Tabby star, named after astronomer Tabetha Boyajian, who first noticed its bizarre light patterns. This isn't your typical variable star. While most stars dim and brighten in regular cycles, Tabby's star drops in brightness by up to 22% at random intervals, sometimes for days or even weeks. Imagine a light bulb that occasionally fades to nearly a quarter of its normal glow, then inexplicably returns to full strength. That's the kind of cosmic anomaly we're dealing with here. At first, astronomers assumed the dimming must come from a swarm of comets, thousands of them, perhaps, trailing enough dust to blot out a significant portion of the star's light. But the numbers didn't add up. To create such drastic dips, you'd need an unimaginable number of comets, far more than any observed in our own solar system. Then came another theory. Maybe it was a vast, uneven dust ring like Saturn's but on a stellar scale. Yet even that struggled to explain the star's long-term dimming trend. Over the past century, Tabby's star has grown noticeably fainter, something no known natural phenomenon fully accounts for. Then, of course, there's the theory that set the internet ablaze. What if the dimming wasn't natural at all? Enter the Dyson sphere hypothesis, the idea that an advanced alien civilization might build a megastructure around their star to harvest its energy. Picture a vast network of solar panels arranged in a shell or swarm, partially blocking the star's light as they rotate. It's a concept straight out of sci-fi, but when all conventional explanations fall short, even the wildest ideas deserve consideration. Still, scientists remain cautious. Recent studies suggest the star's odd behavior could stem from an enormous, misshapen dust cloud or an undetected planetary collision's debris. The truth is, Tabby's star challenges everything we know about stellar physics. Every time we think we've figured it out, it throws another curveball, refusing to fit neatly into any box. That's what makes this cosmic puzzle so thrilling. Whether it's aliens, dust, or something entirely new, Tabby's star forces us to question our assumptions about how stars and perhaps civilizations work. It's a reminder that the universe still holds mysteries we've barely begun to unravel. And as long as this star keeps flickering, astronomers will keep watching, searching for the signal hidden in the noise. Our galaxy, along with thousands of others, is caught in a cosmic current, an invisible river of motion that defies expectation. Somewhere in the depths of space, an immense gravitational force tugs at everything around it, bending the paths of galaxies like a magnet pulling iron filings. Astronomers call this enigma the Great Attractor, and it's one of the universe's most perplexing mysteries. Hidden behind the thick dust and stars of our own Milky Way, this colossal anomaly has eluded direct observation for decades, leaving scientists to piece together its nature through indirect clues and gravitational whispers. The story begins in the 1970s when astronomers mapping the universe's large-scale structure noticed something strange. Galaxies within our local supercluster, including the Milky Way, were all streaming toward a single point in space at staggering speeds, over 600 kilometers per second. This wasn't just random drift, it was a coordinated march, as if some unseen hand were herding them. The problem, the source of this pull, lay in the zone of avoidance, a region of the sky obscured by the Milky Way's glowing bulge and dense dust clouds. It was like trying to study a lighthouse while standing inside its beam. Early estimates suggested the Great Attractor had the mass of tens of thousands of Milky Ways, concentrated in a space roughly 400 million light-years away. But as telescopes peered deeper, the plot thickened. The original Great Attractor, it turned out, was just a waypoint. Beyond it lay something even more massive, the Shapley supercluster, a gargantuan knot of galaxies with gravity so strong, it's likely the true mastermind behind our cosmic drift. Yet even this doesn't fully explain the motion. Some researchers speculate that dark energy, the mysterious force accelerating the universe's expansion, might be warping space-time in ways we don't yet understand, adding another layer to the puzzle. Today, infrared and radio telescopes like the Square Kilometre Array are piercing the zone of avoidance, slowly revealing the hidden architecture of this cosmic tug-of-war. What they find could rewrite our understanding of gravity, dark matter, and the large-scale web that binds the universe together. The Great Attractor isn't just pulling galaxies, it's pulling us toward a deeper truth about how the cosmos really works. Among the countless galaxies scattered across the cosmos, one stands out like a cosmic bullseye. Hoag's object, discovered in 1950 by astronomer Arthur Hoag. This stunning ring galaxy floats in solitude, a near-perfect circle of young blue stars surrounding a golden core of older stars. At first glance, it looks almost artificial, as if some celestial hand carefully painted a glowing halo around a stellar nucleus. But its beauty isn't just skin deep, it's a galactic oddity that challenges our understanding of how galaxies form and evolve. What makes Hoag's object so puzzling is its structure. Unlike spiral galaxies like the Milky Way with their winding arms, or messy ellipticals with their chaotic orbits, this galaxy has no connecting features between its core and outer ring. The two exist in pristine separation, with a dark, nearly starless gap spanning tens of thousands of light years between them. It's as if someone took a typical galaxy and carved out everything but the center and outermost edges, leaving behind a cosmic donut floating in the void. And here's the real kicker: despite decades of study, astronomers still can't agree on how it formed in the first place. One leading theory suggests a violent galactic collision, a smaller galaxy plunging straight through the center of a larger one, sending shockwaves rippling outward that triggered star formation in a perfect ring. The problem: there's no sign of a surviving intruder nearby, no debris trail hinting at an ancient crash. Another idea proposes that Hoag's object is the result of a rare instability in a galactic disk, where gravitational hiccups caused stars to reorganize into two distinct zones. But simulations struggle to recreate such a clean, symmetrical result. Then there's the mystery of the ring itself. The outer band isn't just a static loop, it's actively birthing new stars, glowing with the telltale blue hue of hot, young suns. Yet the core remains eerily calm, packed with older, cooler stars that seem untouched by the frenzy at the galaxy's edge. This stark contrast defies the standard model of galactic aging, where star formation typically starts at the center and spreads outward. Even more curious is the fact that Hoag's object isn't entirely alone. Peering into the gap between its core and ring, astronomers spotted another ring galaxy, smaller and fainter, looming in the cosmic distance. Could this be a clue, a sign that such structures form under specific, poorly understood conditions, or just a dizzying coincidence in an already enigmatic corner of space? Every answer seems to raise new questions, and that's what makes Hoag's object so endlessly fascinating. It's a cosmic outlier, a reminder that the universe sometimes disregards the rulebook entirely. Whether it's the result of a forgotten collision, a gravitational quirk, or something we haven't even considered yet, one thing's clear: this perfect ring in the sky refuses to fit neatly into any box. And perhaps that's exactly why we can't look away. Stretching 25,000 light-years above and below the Milky Way center, two colossal bubbles of searing hot gas defy explanation. Discovered in 2010 by NASA, a Fermi gamma-ray space telescope, these titanic structures, dubbed the Fermi Bubbles, glow with high-energy gamma rays, their edges sharply defined like the walls of a cosmic hourglass. They're not just big, they're violent, each one a roiling testament to some cataclysmic event that shook our galaxy to its core. But what could unleash enough energy to carve such enormous cavities into interstellar space? And why do they still sizzle with radiation millions of years later? The leading suspect, our galaxy's supermassive black hole, Sagittarius A. Normally quiet, this behemoth weighing 4 million times the Sun's mass might have erupted in a frenzied feeding session, devouring an entire star or a massive gas cloud. As material spiraled into its clutches, jets of plasma could have shot outward at near light speed, inflating these monstrous bubbles like cosmic bellows. The shockwaves would have heated surrounding gas to millions of degrees, leaving behind the scorching remnants we see today. It's a scenario backed by computer simulations, where models of black hole outbursts recreate eerily similar structures. But there's a twist. Some researchers argue the bubbles might not be the work of Sagittarius alone. Another possibility points to a frenzy of star formation near the galactic center, where thousands of supernova exploding in quick succession could have pumped enough energy into the galaxy's heart to blow these gargantuan balloons. Think of it like a champagne cork popping, except instead of cork and bubbles, you've got dying stars and shockwaves powerful enough to reshape the galaxy's atmosphere. Then there's the mystery of their shape. Unlike the messy debris clouds left by supernova, the Fermi Bubbles sport unnervingly crisp boundaries, their edges glowing like neon signs in the gamma-ray spectrum. This suggests something, perhaps magnetic fields, is containing them, preventing their energy from dissipating into the void. It's as if the galaxy itself wrapped these structures in invisible cosmic foil, preserving them long after their birth. Even more intriguing, the bubbles are asymmetric. The northern bubble stretches slightly farther than its southern counterpart, hinting at an uneven explosion or an encounter with denser gas on one side. This lopsidedness complicates the puzzle, forcing astronomers to consider whether multiple events, not just one, contributed to their formation. Was it a black hole outburst followed by a starburst, or something entirely different? As telescopes like the upcoming Cherenkov telescope array sharpen our view of these enigmatic structures, one thing's certain: the Fermi Bubbles are more than just galactic decorations. They're scars from a turbulent past, evidence that even our quiet Milky Way has a wild side. Whether forged by a ravenous black hole or a chorus of dying stars, these titanic remnants remind us that galaxies aren't static. They breathe, erupt, and evolve in ways we're only beginning to understand. In the constellation Monoceros, a dying star has sculpted its own cosmic masterpiece, a nebula so precise, it looks like it was sketched with a ruler. The red Rectangle Nebula, first spotted in the 1970s, isn't just another cloud of stellar debris. Its sharp, geometric lines and eerie crimson glow make it one of the most striking anomalies in the night sky, a celestial structure that seems too perfect to be natural. At its heart lies a binary star system, HD 44179, where an aging sun and its companion are locked in a gravitational dance, exhaling layers of gas and dust into space. But instead of forming the usual chaotic swirls of a planetary nebula, their expelled material has arranged itself into a near-perfect X-shape, with ladder-like rungs of glowing red gas connecting the arms. The result, a structure so symmetrical it resembles a stained glass window lit from within. What gives the red rectangle its haunting crimson hue? The answer lies in a rare type of organic molecule known as polycyclic aromatic hydrocarbons, or PAH. These carbon-based compounds, often found in soot and interstellar dust, fluoresce when bombarded by ultraviolet light from the central stars, painting the nebula in shades of deep red. But there's something even stranger hiding in the spectral data: hints of crystalline carbon, possibly in the form of tiny diamonds. Yes, diamonds. Under the intense conditions near the dying star, carbon atoms may have aligned into microscopic crystals, scattering light in ways that amplify the nebula's unearthly glow. Imagine trillions of nanodiamonds, each smaller than a grain of sand, suspended in the cosmic winds, a glittering fog woven into the nebula's fabric. Yet the real puzzle is the shape. How does a dying star produce such crisp, angular structures in the mess of space? The leading theory points to the binary star's tightly choreographed orbit. As one star sheds its outer layers, the other's gravity funnels the material into two opposing cones, like sand pouring through an hourglass. Viewed edge-on, these cones form the iconic X, while shockwaves from stellar winds carve the ladder like rungs. It's a delicate balance. One wrong gravitational nudge, and the symmetry would collapse into chaos. That's what makes the red rectangle so extraordinary. It's a fleeting moment of cosmic precision, a stellar swan song composed with mathematical grace. But the nebula's beauty won't last. In a few thousand years, the central stars will finish their transformation into white dwarfs, their radiation fading until the red rectangle dims into obscurity. For now, though, it stands as a testament to the universe's ability to blend art and science, a reminder that even in death, stars can leave behind wonders that defy imagination. And who knows, those speculated diamonds might be more than just a curiosity. If future probes could someday sift through the nebula's dust, they might find a treasure trove of celestial gems forged in the heart of a dying star. Galaxies don't just drift, they flow, caught in a current so vast it defies the very fabric of our universe. Astronomers call it the dark flow, and it's one of cosmology's most unsettling mysteries. Imagine throwing a handful of leaves into a river, only to watch them all surge in the same direction against the current. That's what's happening to entire galaxy clusters, millions of them, all streaming toward a single point in space beyond the edge of everything we can see. This isn't just random motion, it's a coordinated march, as if some unseen force is tugging at the cosmos from the outside. The discovery came in 2008, when researchers studying the cosmic microwave background, the afterglow of the Big Bang, noticed something bizarre. Galaxy clusters weren't just expanding with the universe, they were showing minute but consistent velocity shifts, all pointing toward the same distant void. The numbers were staggering. These clusters were racing at speeds up to 1,000 kilometers per second, far faster than anything gravity from known matter could explain. Even stranger, the flow extended beyond the observable universe's horizon, suggesting whatever was pulling them lay in realms we'll never see. It's as if the universe is tipping its hand, hinting at something out there, something colossal enough to bend space-time on a scale we can barely fathom. Theories abound, each wilder than the last. Some scientists propose the dark flow is evidence of a neighboring universe, a parallel cosmos with its own gravity tugging at ours through some higher dimensional thread. Others speculate it's the imprint of a pre-Big Bang reality, a scar left behind when our universe was born. Then there's the unsettling possibility that our entire cosmic neighborhood is caught in the wake of an ancient universe-sized collision, a crash so titanic its ripples still steer galaxies billions of years later. But the most contentious idea, that we're seeing the fingerprints of modified gravity, maybe Einstein's equations, the bedrock of modern cosmology, need revision on the largest scales. If true, it would upend everything we know about dark matter, dark energy, and the universe's fundamental rules. Yet even this radical theory struggles to fully explain the dark flow's sheer scale and precision. The debate rages on, fueled by new data from telescopes like Planck and future projects like the Euclid Space Observatory. With every measurement, the mystery deepens. Either we're missing something fundamental about the cosmos, or we're staring at the first evidence of a reality far stranger and far grander than we ever dared imagine. The dark flow doesn't just challenge our models, it whispers of a universe teeming with secrets, where even the emptiest voids hum with unseen motion. And that's the most thrilling part. The unknown isn't a wall, it's a door. Most of space is crowded with galaxies swirling, colliding, bursting with stars. But in the constellation Boötes, there's a hole in the universe, a void so vast and empty it defies logic. Stretching 330 million light-years across, the Boötes void isn't just a quiet corner of the cosmos. It's a staggering nothingness, a region where galaxies should exist by the thousands, yet fewer than 60 have been found. If you place the Milky Way in its center, our nearest galactic neighbor would be so far away, humanity might never have noticed other galaxies existed. This isn't just a gap, it's a cosmic desert on a scale that shouldn't be possible. So how does a void this enormous form? The leading theory points to the early universe just moments after the Big Bang. Tiny fluctuations in density could have created vast bubbles as space expanded, some packed with matter, others left eerily hollow. Over billions of years, those bubbles grew, and the Boötes void might be one of them, a relic of our universe's chaotic infancy. But there's a problem. Even the largest predicted bubbles shouldn't be this empty. Simulations struggle to recreate a void so barren without invoking something stranger, like the gravitational influence of parallel universes nudging matter away, or exotic physics we haven't yet imagined. Then there's the darker, more speculative idea. Could the void be artificial? Some theorists, though far from the mainstream, suggest a civilization harnessing the energy of entire galaxies might eventually leave behind such a vacuum. Picture a Kardashev Type 3 civilization, so advanced they've dismantled galaxies for resources, leaving only darkness in their wake. It's an unsettling thought, one that turns the void from a cosmic oddity into a potential monument to something beyond our comprehension. Yet the truth is likely simpler and no less fascinating. Recent observations hint that the Boötes void might not be as empty as we thought. Ultra-faint dwarf galaxies, nearly invisible to our telescopes, could be hiding in the darkness, their dim light undetected. If so, the void might just be a trick of perspective, a reminder that the universe still holds shadows we can't quite pierce, but that's the allure of this great nothing. It's a blank space on the map, a challenge to our assumptions about how the cosmos organizes itself. Whether it's a fossil from the Big Bang, a sign of undiscovered physics, or something even weirder, the Boötes void forces us to confront an uncomfortable truth. Sometimes the most profound mysteries aren't about what's out there, but what isn't. Somewhere in the constellation Serpens, a world made of solid diamond circles the corpse of a dead star. This isn't science fiction, it's PSRJ 1719-1438b, a planet so dense, so bizarre, it defies everything we know about planetary formation. Discovered in 2011, this cosmic gem orbits a pulsar, a rapidly spinning neutron star that beams radiation like a lighthouse. But the real marvel lies in the planet's composition. Crystallized carbon, compressed under unimaginable pressure into what might just be the galaxy's most extravagant diamond. At 5,000 kilometers wide, it's not just a few carats, this thing is planet-sized. How does something so extreme come to exist? The story begins with a stellar apocalypse. Billions of years ago, the pulsar at the system's heart was once a massive star. When it exhausted its fuel, it exploded in a supernova, leaving behind a tiny, ultra-dense remnant no bigger than a city but weighing more than our sun. Nearby orbited a companion star, a white dwarf made mostly of carbon and oxygen, the cosmic leftovers of a smaller sun. Over eons, the pulsar's gravity siphoned material from the white dwarf, stripping it down to its core. What remained was a bare, carbon-rich husk, no longer a star, but not quite a planet either. Under the pulsar's relentless pull, that carbon compressed until its atoms aligned into a crystalline lattice. The result, a diamond the size of a world glittering in the dark. Yet PSRJ 1719-1438b isn't just a celestial jewel. It's a laboratory for extreme physics. The planet orbits its pulsar in just 2 hours and 10 minutes, so close you could fit the entire system inside our sun. At that range, the pulsar's radiation bathes the diamond surface in deadly X-rays, while tidal forces keep one hemisphere permanently locked in scorching daylight and the other in frigid darkness. If you stood on its surface, ignoring the fact you'd be crushed instantly, the sky would be dominated by a spinning, strobe-like pulsar, its beams slicing through the darkness like a cosmic scythe. What fascinates scientists most isn't just the planet's composition, it's the mystery of how it survived at all. Pulsars are notorious for obliterating nearby objects with their radiation and gravity. That this diamond world persists suggests an incredible resilience, or perhaps a formation story even stranger than we've guessed. Some researchers speculate it might be the core of a helium star, a rare type of stellar remnant that could explain its purity and density. Others wonder if it's part of a larger, undiscovered population of diamond planets, celestial oddities forged in the crucible of dying stars. Then there's the tantalizing question of what lies beneath its surface. Diamond is just one form of carbon. Under even greater pressure, it could transform into something even stranger, metallic hydrogen, or perhaps phases of matter we've never seen. The planet's interior might be a layer cake of exotic materials, each more bizarre than the last, waiting to rewrite the textbooks on planetary science. For now, PSRJ 1719-1438b remains a cosmic paradox, a world born from destruction, a diamond forged in stellar fire. It challenges our assumptions about how planets form and what they're made of, proving once again that the universe has a flair for the extravagant. And while it's far too distant, too hostile to ever mine, its very existence sparks the imagination. After all, if there's one diamond planet out there, who's to say there aren't more? The cosmos, it seems, has a way of turning even the most outlandish fantasies into reality. At the heart of the Virgo cluster, a cosmic titan rules with a voracious appetite, Messier 87, a galaxy so massive it bends the rules of galactic survival. This isn't just any elliptical galaxy. It's a celestial predator, a gravitational bully that spent billions of years consuming smaller neighbors, growing larger with every galactic feast. Stretching over 120,000 light-years and weighing in at 2.4 trillion times the mass of our Sun, Messier 87 doesn't just dominate its corner of the universe, it reshapes it. The evidence of its cannibalism is written in the stars. Telescopes have spotted vast streams of stellar debris, tidal tails wrapping around Messier 87 like cosmic spaghetti, the torn apart remains of galaxies it's absorbed. Some of these streams stretch hundreds of thousands of light-years, ghostly trails of stars that once belonged to independent systems before being ripped apart by the giant's relentless gravity. Even globular clusters, dense knots of ancient stars that normally orbit galaxies like loyal satellites, appear in numbers that defy logic. Messier 87 hosts thousands of them, far more than the Milky Way's 200, many likely stolen from devoured victims. But the real spectacle lies at its core. Nestled within Messier 87's glowing center is a monster, a supermassive black hole weighing 6.5 billion solar masses. This isn't just any black hole, it's the first one humanity ever saw. In 2019, the Event Horizon Telescope collaboration unveiled its groundbreaking image, a fiery ring of light encircling the black hole's shadow, a visual confirmation of Einstein's predictions in the most extreme environment imaginable. That glowing ring, superheated plasma, swirling at nearly light speed before plunging into oblivion. Yet this black hole isn't just sitting quietly. It's firing a jet of plasma over 5,000 light-years into space, a beam of energy so powerful it outshines the entire galaxy at certain wavelengths. This jet, moving at 99% the speed of light, is the aftermath of the black hole's messy eating habits. As gas, dust, and even stars spiral toward their doom, magnetic fields funnel some of the material outward, launching it into the void like a cosmic blowtorch. The precision of this jet is absurd. It's almost perfectly straight, a testament to the black hole's astonishing spin and the galaxy's intricate magnetic scaffolding. What makes Messier 87 truly humbling is its scale of destruction. While our Milky Way quietly nibbles on dwarf galaxies like the Sagittarius dwarf, Messier 87 consumes galaxies larger than our own. Simulations suggest it's swallowed dozens over its lifetime, growing fatter with each merger. Some astronomers speculate it might even absorb the entire Virgo cluster one day, becoming a supergalaxy in a future so distant, our Sun will have long since burned out. And here's the chilling part, we're not just spectators to this carnage. The Milky Way is part of the Virgo supercluster, slowly drifting toward Messier 87's gravitational grasp. Don't panic, it'll take billions of years before we're anywhere near its reach. But this cosmic juggernaut serves as a stark reminder, the universe isn't a peaceful place. It's a battlefield where giants like Messier 87 rewrite the rules, proving that even galaxies must eat or be eaten. In 2020, astronomers stumbled upon something that shouldn't exist: massive rings of radio energy floating in the depths of space like ghostly halos. Dubbed odd radio circles or ORC, these enigmatic structures span hundreds of thousands of light-years, dwarfing entire galaxies. Yet the strangest part: no one knows what they are. They don't emit visible light, X-rays, or any other detectable radiation, just these eerie, perfect loops of radio waves invisible to optical telescopes. If you could see them with your eyes, they'd blot out chunks of the night sky, cosmic bullseyes hiding in plain sight. Their discovery was almost accidental. Researchers using the Australian Square Kilometre Array Pathfinder, a powerful radio telescope, were training an AI to sift through mountains of data when the algorithm flagged something bizarre, faint, circular signals that didn't match any known celestial object. At first, scientists assumed it was a glitch, an artifact of telescope calibration. But as more ORCs emerged in the data, the truth became unavoidable. These were real and they were everywhere. 5 were confirmed within months, each one a perfect circle, some with galaxies nestled at their centers, others floating in emptiness. The cosmic rulebook had just gained a new chapter, one written in riddles. Theories about their origins range from the plausible to the fantastical. One leading idea suggests ORCs are shockwaves from colossal explosions, perhaps the aftermath of 2 supermassive black holes merging, sending gravitational ripples through intergalactic gas that ignite these radio rings. Imagine tossing a stone into a pond, except the pond is the fabric of space, and the stone weighs billions of suns. Another proposal points to starburst galaxies, where frenzied star formation generates galactic winds so powerful they carve bubbles into the surrounding medium, lighting up in radio waves as they expand. But the wildest hypothesis, ORCs might be the throats of wormholes, their immense gravitational lenses bending radio emissions into circular mirages. Or, as some daring researchers speculate, they could be signatures of alien megastructures, cosmic lighthouses built by civilizations advanced enough to manipulate entire galaxies. It's a long shot, but the sheer scale of these rings forces astronomers to consider all possibilities, no matter how improbable. What makes ORCs so thrilling isn't just their mystery, it's how they expose the limits of our knowledge. Here we are, mapping the universe in exquisite detail, only to be blindsided by something as simple as a circle. They remind us that space still holds colossal secrets, phenomena so vast we've barely begun to notice them. And with new radio telescopes coming online, one thing's certain: the deeper we look, the stranger the cosmos gets. In 1572, astronomers across the globe witnessed a brilliant new star blazing in the constellation Cassiopeia, so bright it outshone Venus and became visible even in daylight. This was Tycho's supernova, named after the famed astronomer Tycho Brahe, who meticulously documented its gradual fade over 18 months. For centuries, it was a textbook example of a Type Ia supernova, the explosive death of a white dwarf star. But in 2012, astronomers made a jaw-dropping discovery. The star wasn't dead. Against all odds, it had survived. Dubbed the zombie star, this cosmic anomaly refuses to play by the rules, forcing scientists to rewrite the book on how stars die, or in this case, don't. For decades, the prevailing theory was straightforward. When a white dwarf, the dense core of a dead star, siphons too much material from a companion, it crosses a critical mass threshold and detonates in a thermonuclear blast so violent it obliterates the star completely. No remnant, no corpse, just scattered debris. That's why Tycho's supernova remnant, a gauzy bubble of gas 6,500 light-years away, was assumed to be a celestial gravestone. Then came the Hubble Space Telescope's bombshell observation. Deep inside the debris field, something was moving. Not just drifting gas, but a star, hurtling through the wreckage at 3 times the speed of its neighbors. Spectral analysis revealed it was a white dwarf, the very same type of star supposedly destroyed in the explosion. This shouldn't be possible. A Type Ia supernova is supposed to be a star's final act, a total self-destruction with no survivors. Yet here was the culprit itself, seemingly unscathed. The implications sent shockwaves through astrophysics. Had the star somehow failed to fully explode, leaving a charred remnant behind? Or was this a new breed of supernova altogether, one where the white dwarf endures the blast like a boxer walking away from a knockout punch? The leading explanation is as bizarre as the star itself. Simulations suggest the zombie star might have pulled off a cosmic Houdini act by undergoing a partial detonation. Picture a bomb that only half explodes enough to fling debris into space but leaving its core intact. In this scenario, the white dwarf's outer layers ignited unevenly, ejecting just enough material to create the visible remnant while the dense heart of the star held firm. It's a delicate balancing act requiring conditions so precise, some astronomers argue it should be nearly impossible. Yet the evidence is undeniable: this star cheated death. Even stranger is the star's blistering speed. The explosion likely gave it a gravitational slingshot kick, sending it careening through space like a bullet. That motion is a clue, a telltale sign that this star wasn't a passive bystander. It was the engine of its own destruction, but the mysteries don't stop there. The zombie star's atmosphere shows traces of unburned carbon and oxygen, elements that should have been fused into heavier metals during the supernova. Their presence hints that the explosion was somehow incomplete, like a firework that fizzled instead of bursting. The discovery has forced astronomers to reconsider everything they thought they knew about stellar deaths. If white dwarfs can survive supernova, even rarely, it means these explosions aren't the uniform cosmic yardsticks we've relied on to measure the universe's expansion. It also raises a tantalizing question: how many other dead stars are actually still out there, lurking in old supernova remnants waiting to be found? Tycho's zombie star is more than a curiosity. It's a cosmic rebel, a celestial phoenix that defies the natural order. Whether it's a fluke or the first of many, one thing's clear: the universe has a way of keeping even the most fundamental truths just out of reach. And that's what makes this undead star so thrilling. It's not just challenging our models, it's daring us to imagine new ones. If you could strip away every star, galaxy, and speck of light from the universe, you'd still find its hidden architecture, an intricate, invisible skeleton stretching across billions of light years. This is the cosmic web, a vast network of dark matter and hot gas filaments weaving through the emptiness like threads in a tapestry. These aren't just abstract lines on a map. They're the universe's scaffolding, the hidden highways that guide galaxies into clusters and shape everything we see. And while the web itself is too faint to spot with traditional telescopes, its fingerprints are everywhere, dictating where stars ignite, where galaxies collide, and even where we ended up. The cosmic web's existence was first hinted at in the 1970s, when astronomers noticed galaxies weren't scattered randomly. Instead, they clustered along faint, thread-like patterns, like beads on a string. But it wasn't until the 21st century that simulations revealed the full picture. Dark matter, that mysterious substance making up 85% of the universe's mass, forms an immense spiderweb-like structure under its own gravity. Where these filaments intersect, galaxies gather. Where they thin out, voids like the Boötes void yawn empty. It's a blueprint written in shadow, one that took supercomputers running for months to decode. Then came the breakthrough, a way to see the invisible. In 2012, researchers using the Hubble Space Telescope turned the web's gas filaments into a ghostly glow. How? By exploiting distant quasars, the brilliant cores of ancient galaxies, as cosmic flashlights. As their light traveled through the filaments, certain wavelengths were absorbed, revealing the presence of ionized oxygen and hydrogen heated to millions of degrees. The result, the first direct snapshot of the web's tendrils, shockingly long and razor-thin, some stretching 500,000 light-years between galaxies. But the real marvel is how these filaments work. Picture a river of gas flowing along a dark matter channel, funneling raw material into galaxy clusters like water rushing into a drain. Without this steady supply, galaxies would starve, their star formation sputtering out. The web doesn't just connect the cosmos, it feeds it, and occasionally it overfeeds. When too much gas piles up at a filament's intersection, it can trigger a frenzy of star birth, lighting up galactic collisions or birthing supermassive black holes. Yet the web isn't static. It breathes, vibrates, and evolves. Recent simulations show filaments snapping under their own tension, recoiling like broken rubber bands and flinging galaxies into the void. Others pulse with shockwaves from long-ago supernova, their ripples stirring the gas into turbulent currents. And somewhere out there, new filaments are forming, stretching into the expanding universe like roots seeking water. What's most humbling is realizing we're inside this web. The Milky Way sits at the edge of a filament, part of the Laniakea supercluster, a structure so vast it makes our galaxy feel like a single leaf on a redwood tree. Every time we look up, we're glimpsing not just stars, but the hidden threads that bind them together. The cosmic web isn't just a curiosity, it's the reason we're here at all. And as telescopes grow sharper, we're just beginning to trace its full pattern, a map of the universe's darkest, most vital veins. Saturn isn't just a ringed beauty, it's a planet of puzzles, and none are more mesmerizing than the colossal hexagon swirling at its north pole. This isn't some trick of camera angles or digital artifacts. It's a real six-sided hurricane, wider than two Earths stacked side by side, spinning with mathematical precision for at least 4 decades, possibly much longer. Imagine a storm so vast it could swallow our planet whole, yet shaped like a honeycomb cell carved into the sky. What kind of cosmic forces could sculpt such a perfect geometric tempest, and why does it refuse to fade like earthly hurricanes? The hexagon was first spotted in the early 1980s by NASA Voyager missions, but it wasn't until Cassini arrived in 2004 that scientists grasped its sheer strangeness. Unlike the chaotic swirls of Jupiter's Great Red Spot, this storm's edges are razor-straight, its 60-mile-per-hour winds tracing a near-flawless hexagon as if guided by an invisible ruler. Even more baffling, the structure reaches hundreds of miles deep into Saturn's atmosphere, anchoring itself like a colossal atmospheric drill bit. Earth's most violent hurricanes dissolve in weeks, yet this alien polygon has outlasted generations of human observers. So how does a hexagon form in a gaseous planet's sky? The leading theory points to Saturn's rapid rotation. A day there lasts just 10.5 hours, combined with jet streams moving at different speeds. Laboratory experiments suggest that when fluids or gases rotate at varying velocities, they can produce stable polygonal shapes. Picture stirring a cup of coffee just right, creating temporary geometric ripples. Except on Saturn, the coffee is a mix of hydrogen, helium, and ammonia, and the cup is the size of a planet. The hexagon might be a standing wave, a sort of atmospheric resonance frozen in time by Saturn's unique dynamics. Yet the storm's persistence is what truly stumps researchers. Earth's weather systems are chaotic, shaped by oceans, landmasses, and temperature swings. Saturn, by contrast, is a fluid world with no solid surface to disrupt airflow, a perfect incubator for long-lived storms. Some scientists speculate the hexagon's longevity comes from its depth, tapping into energy from Saturn's interior to sustain itself like a planetary-scale heat engine. Others wonder if the shape itself is the key. Its geometry minimizing energy lost the way a beehive's hexagons optimize space. But the biggest surprise came when Cassini observed the hexagon change color. Over Saturn's 30-year orbit, the storm shifted from bluish hues to golden tones, likely due to seasonal shifts in sunlight and atmospheric chemistry. This wasn't just a static oddity, it was a dynamic, evolving system, as alive as any weather pattern on Earth. The hexagon remains one of the solar system's most hypnotic mysteries. It challenges our understanding of fluid dynamics, atmospheric science, and even geometry itself. Whether it's a freak of physics or a signature of deeper planetary processes we've yet to uncover, one thing's clear: Saturn doesn't just wear rings, it wears a crown, a six-sided enigma spinning silently in the dark. And as long as it lingers, it'll keep daring us to unravel its secrets. The pillars of creation are cosmic royalty, towering spires of gas and dust immortalized by the Hubble Space Telescope in 1995. These ethereal fingers, stretching 4 light-years high in the Eagle Nebula, became the poster child of cosmic beauty, a nursery where newborn stars flicker to life within dense cocoons. But here's the haunting truth: we might be staring at a ghost. Evidence suggests these iconic pillars could already be gone, reduced to stardust by a cataclysm we won't witness for centuries. The clue lies in the violence of their neighborhood. The Eagle Nebula sits 7,000 light-years away, meaning every image we see is a snapshot from 7,000 years in the past, around the time humans were inventing the wheel. In 2015, NASA's Spitzer Space Telescope detected a shockwave of heat rolling through the region, likely the aftermath of a nearby supernova. Infrared readings showed the pillars' tips glowing suspiciously warm, as if they'd been scoured by a blast wave traveling at 1,000,000 miles per hour. Simulations painted an apocalyptic scenario. A massive star, unseen in Hubble's optical images, may have already exploded, sending a tsunami of radiation barreling toward the pillars. Given their fragile composition, lofted gas held together by gravity, such a shockwave would rip them apart like sandcastles in a hurricane. Yet we won't know for sure until the light from their destruction finally reaches Earth. It's a cosmic time warp, forcing us to confront the unsettling reality that some of the universe's most famous landmarks might only exist as echoes. Even Hubble's 2014 revisit, with its sharper, deeper details, can't settle the debate. Those newer images reveal subtle changes, evaporating tendrils, newborn stars punching holes in the gas, but definitive proof of the pillar's demise remains just out of frame, racing toward us at the speed of light. What makes this mystery so poignant is the duality it represents. The pillars of creation are both a testament to stellar birth and a memento mori for cosmic structures. They remind us that the universe doesn't operate on human timescales. A celestial icon can vanish in an instant yet linger in our skies for millennia, a phantom of its former self. Whether they're still standing or not, their legacy endures, teaching us that destruction and creation are two sides of the same cosmic coin. And when the truth finally arrives, it'll rewrite the story of one of space's most famous landscapes, proving that even the universe's grandest monuments are fleeting. Out in the depths of the cosmos, a mystery orbits a distant world, a moon so enormous it defies everything we thought possible. Meet Kepler 1625b, the first and only exomoon ever detected, a gargantuan satellite circling a planet 8,000 light-years away. This isn't just any moon, it's the size of Neptune, dwarfing every moon in our solar system and challenging our understanding of how celestial partnerships form. But here's the catch: not everyone believes it's real. The saga began in 2017 when astronomers poring over data from the Kepler Space Telescope noticed something peculiar about the gas giant Kepler 1625b. As it transited its star, blocking a fraction of the light, there were two dips in brightness, one for the planet and a second, smaller one trailing behind. The timing and shape of that second dip hinted at a moon's gravitational tug, distorting the planet's path like a dog on a leash. Follow-up observations with the Hubble Space Telescope seemed to seal the deal. The planet's transit started 75 minutes early, a telltale sign of a massive companion yanking it off course. The numbers were staggering. If real, this moon would weigh in at nearly 2% of its host planet's mass, making it 10,000 times heavier than Earth's moon relative to its parent. Yet almost immediately, skeptics raised their eyebrows. Moons this massive shouldn't exist, at least not according to our current models. In our solar system, moons form one of two ways. Either they coalesce from debris left over after planetary formation, like Earth's moon, or they're captured by a planet's gravity, like Neptune's Triton. But a Neptune-sized moon, that's planet-sized. Forging or capturing something so enormous would require a perfect storm of conditions. a cosmic fluke so rare it borders on impossible. Critics argue the Hubble data might be a mirage. Stellar activity spots or flares on the star's surface could mimic the signature of a moon. Others point to quirks in the telescope's instruments, suggesting calibration errors might have created a false signal. Even the gravitational tug could have alternative explanations. What if the planet isn't alone? A hidden second planet in the system, lurking just out of view, could tug on Kepler 1625b, masquerading as a moon's influence. The debate rages on, with each new study swinging the pendulum. In 2020, a reanalysis of the Hubble data claimed the moon signal vanished when accounting for subtle instrumental effects. But in 2022, another team doubled down, asserting the moon's presence was still the cleanest explanation. The truth might lie in waiting. Upcoming telescopes like the James Webb Space Telescope could settle the argument with their razor-sharp infrared eyes, spotting the moon's heat signature or ruling it out entirely. What makes this cosmic tug of war so thrilling isn't just the question of whether Kepler 1625b exists, it's what its existence would mean. A moon this massive would rewrite the rules of lunar formation, forcing us to consider scenarios we've never dreamed of. Maybe it's a captured rogue planet snatched by its host in a celestial wrestling match. Or perhaps it's the survivor of a catastrophic collision, the last remnant of a shattered world. Either way, it's a reminder that the universe loves to defy expectations. Whether this impossible moon is confirmed or debunked, one thing's certain: the hunt for exomoons just got a lot more interesting. Some planets don't play by the rules. While most worlds orbit stars like obedient children, others break free, wandering the cosmos alone, untethered and untamed. Meet CFBD SIR 2149-0403, a rogue planet drifting through interstellar space without a sun to call home. This isn't just a lone wolf, it's a cosmic rebel defying everything we thought we knew about how planets form and survive. Discovered in 2012, this nomad floats just 40 light-years away in the constellation Dorado, close enough for astronomers to study its eerie glow. Unlike Earth, which soaks up sunlight, CFBD SIR 2149-0403 generates its own faint warmth, radiating heat left over from its chaotic birth. Infrared telescopes revealed a temperature of around 700 degrees Fahrenheit, hot enough to melt lead, but far colder than any star. At just 4 to 7 times Jupiter's mass, it blurs the line between planet and failed star, a celestial oddity too small to ignite fusion yet too massive to fit neatly into planetary categories. What makes rogue planets like this so baffling is their origin story. Traditional planet formation hinges on star systems where dust and gas swirl around young suns, clumping into worlds over millions of years. But CFBD SIR 2149-0403 has no star. So how did it form? One theory suggests it was violently ejected from its birthplace, flung into the void by gravitational turmoil. Picture a young solar system in chaos, with planets slingshotting past one another until one gets hurled into the abyss. Simulations show this isn't just possible, it might be common, with billions of rogue planets adrift in our galaxy alone. Yet there's another, wilder possibility. Maybe this planet never had a star. Some astronomers speculate rogue planets could form directly from collapsing gas clouds like stars do, but without enough mass to shine. These free-floating worlds would emerge from tiny, isolated pockets of gas, bypassing the need for a stellar parent entirely. If true, it would mean planets aren't just accessories to stars, they're independent entities, capable of carving their own path through the cosmos. The implications are staggering. Rogue planets could outnumber stars in the Milky Way, lurking in the dark like cosmic ghosts. Some might even harbor life, warmed by geothermal vents or thick atmospheres trapping heat. Imagine subterranean oceans beneath icy crusts, thriving in perpetual darkness, an ecosystem untouched by sunlight, surviving on chemistry alone. It's a tantalizing thought, one that redefines the very boundaries of habitability. But CFBD Sir 2149-0403 holds another mystery: its motion. This planet isn't just drifting, it's racing, moving in tandem with a group of young stars called the AB Doradus Moving Group. That kinship suggests it might have been born with them, a clue to its turbulent past. Yet its exact ties remain unclear, leaving astronomers to wonder if it's a fugitive from this stellar family or just a passerby caught in the same cosmic current. What's certain is that rogue planets force us to rethink the diversity of planetary existence. They're proof that the universe doesn't need stars to craft worlds, just gravity, time, and a touch of chaos. And as telescopes grow sharper, who knows how many more of these cosmic drifters we'll find, rewriting the rules one lonely world at a time. In the vast stellar graveyard of our galaxy, one corpse shines with an eerie sapphire glow, the Blue Ring Nebula. Discovered in 2020 after 16 years of mystery, this celestial oddity is unlike anything astronomers had seen before. At its heart lies a collapsed stellar duo, the smoldering remains of two stars that collided and merged. But it's the aftermath that stuns, a vast ultraviolet ring blooming outward like a cosmic bruise, visible only in wavelengths far beyond what our eyes can perceive. This isn't just a nebula, it's a time capsule capturing a fleeting phase of stellar evolution so rare we've never caught one in the act until now. The Blue Ring Nebula's story begins with a violent cosmic tango. Thousands of years ago, a pair of stars likely similar in size to our Sun spiraled too close, locked in a gravitational death grip. As they merged, the larger star shredded its companion, flinging debris into space while the surviving core recoiled, shrouded in a superheated disk of vaporized star stuff. Normally, such chaos would fade into obscurity, but here something extraordinary happened. The collision's shockwaves lit up a colossal donut of hydrogen gas, previously ejected by the dying stars, causing it to fluoresce with an intense blue hue in ultraviolet light. The result, a perfect glowing halo suspended in the void, with the merged star flickering at its center like an ember in a sapphire storm. What fascinates scientists most isn't just the nebula's beauty, it's its transience. This ultraviolet ring is a cosmic blink, a phase lasting maybe thousands of years against the universe's billions. By the time its light reached Earth, the actual event was long over, the nebula likely already fading. We're witnessing a stellar metamorphosis mid-transformation, like catching a caterpillar halfway through becoming a butterfly. Most merged stars are found after this stage, their origins obscured. The Blue Ring Nebula is our first clear snapshot of the process, a missing link between stellar death and rebirth. Yet mysteries linger. The nebula's structure defies expectations. Its ring isn't smooth but clumpy, with dense knots of gas suggesting turbulence in the merger's aftermath. Even stranger, the central star shows signs of a companion, a potential third actor in this celestial drama. Some theorize the original duo might have been a triple system, with the surviving star now encircling the merged remnant in a wide, uneasy orbit. Others speculate the ring might actually be twin cones of gas, their shape distorted by our perspective, like headlight beams piercing cosmic dust. Perhaps the most tantalizing question is what comes next. Merged stars often evolve into bizarre objects, blue stragglers, vampire stars, or even magnetas. The Blue Ring Nebula's central remnant, still cooling from its violent rebirth, could one day erupt anew or fade into a husk. Telescopes like Hubble and JWST continue to monitor it, decoding its ultraviolet whispers for clues. Each observation peels back another layer, revealing how stars rewrite their fates through catastrophe. This nebula is more than a space oddity. It's a Rosetta Stone for stellar collisions, a fleeting masterpiece painted in hydrogen and time. And its greatest lesson, even in destruction, the cosmos finds ways to dazzle, turning chaos into light. Black holes aren't supposed to hide in plain sight, especially not in our own cosmic backyard. But in 2020, astronomers stumbled upon the unicorn, a black hole so small, so sneaky, it had been lurking just 1,500 light-years away without anyone noticing. Weighing in at a mere 3 times the mass of our Sun, this cosmic runt is the smallest stellar black hole ever discovered, and its very existence challenges the limits of how we hunt for these invisible predators. The unicorn's discovery reads like a detective story written by the universe itself. Researchers weren't even looking for black holes when they noticed something odd about a nearby red giant star. Its light pulsed rhythmically, not from its own internal processes, but as if an unseen object were tugging on it like a puppeteer. The culprit, an invisible companion, far too dense to be a neutron star, warping the star's shape with its gravity. No X-ray flashes, no glowing accretion disk, just the faintest distortion in starlight, a whisper of presence in an ocean of data. That's how you find a black hole playing dead. What makes the unicorn so extraordinary isn't just its size, it's how it defies the black hole mass gap. For decades, astronomers assumed stellar black holes couldn't form below 5 solar masses. Anything smaller would collapse into a neutron star instead. Yet here was this tiny phantom slipping through the theoretical cracks. Its discovery suggests a hidden population of petite black holes might be scattered throughout the galaxy, overlooked because they don't behave like their larger, flashier cousins. Imagine an entire universe of shadows quietly tugging at stars we thought were alone. But the real marvel is how it was found. Most black holes reveal themselves by devouring nearby gas, superheating it into telltale X-rays. The unicorn, though, is starving no nearby material to consume, no dramatic outbursts. It's a black hole in hibernation, detectable only through its gravitational fingerprint on a single, patient star. Statistically, spotting such an object was like finding a needle in a haystack the size of a planet. Researchers had to sift through decades of stellar surveys, searching for subtle patterns buried in noise. That they found it at all is a testament to how much we've underestimated the cosmos's ability to surprise us. Now the hunt is on for more of these cosmic phantoms. If the unicorn isn't a fluke, it could reshape our understanding of stellar death, hinting at exotic physics that allow stars to collapse into black holes at lower masses than we thought possible. Or perhaps it's the remnant of a black hole that's been slowly evaporating over eons, a cosmic ember fading into the dark. Either way, its quiet presence in the cosmic ledger proves one thing. Sometimes the universe hides its greatest wonders not in the glaring spotlight, but in the spaces between the data, waiting for someone to look closer. Deep within the constellation Draco, a cosmic tadpole swims against the current of the universe, a galaxy stretched and twisted into a shape that defies the serene spirals and smooth ellipses we're used to. The Tadpole Galaxy, officially known as UGC 10214, is a spectacle of gravitational chaos, its long, shimmering tail of stars trailing behind like the wake of a ship sailing through the void. This isn't just a pretty anomaly, it's a fossilized record of one of the universe's most violent events, a galactic collision frozen in time. What makes the tadpole so mesmerizing is its tail, a stream of stars and gas stretching an astonishing 280,000 light-years, nearly 3 times the diameter of our Milky Way. To put that in perspective, if our solar system were a grain of sand, this tail would be longer than a football field. And it wasn't born this way. Around 100 million years ago, the tadpole had a fateful encounter with a smaller intruder galaxy, a cosmic bully that barged in, grazed its edge, and sent shockwaves rippling through its structure. The smaller galaxy's gravity acted like a tidal force, plucking stars and gas from the tadpole's outskirts and flinging them into space like confetti in a hurricane. The result, a celestial comet, its tail a glittering trail of orphaned stars and nurseries where new suns ignite amid the chaos. But the real treasure lies in what this collision reveals. The tadpole's tail isn't just debris, it's a time machine. Embedded within its arc are clusters of young, blue stars, their brilliance standing out against the older, yellower stars of the tadpole's main body. These stellar infants shouldn't exist out there in the galactic hinterlands, where gas and dust are usually too sparse to trigger star formation. Their presence tells us something extraordinary. Galactic collisions don't just destroy, they create. The shockwaves from the encounter compressed pockets of gas, igniting bursts of star birth in the most unlikely places. It's a reminder that even in the vast, cold reaches of intergalactic space, chaos can spark new life. Yet the tadpole story isn't over. Simulations suggest its tail will eventually dissolve, its stars scattering into the void like embers from a firework. The intruder galaxy, now long gone, will continue its journey, leaving behind no trace but this shimmering scar. And in a few billion years, the tadpole itself will settle into a new shape, perhaps a bland elliptical galaxy, its turbulent past erased. That's the bittersweet lesson of the tadpole galaxy. The universe is in constant flux, reshaping itself through collisions and near misses, leaving behind these fleeting masterpieces as clues to its restless nature. For now, though, it drifts through the cosmos, a silent witness to the forces that build and break galaxies, and a reminder that even the grandest structures in the universe are just temporary works of art. There's a star in the southern sky so volatile, it makes supernova look tame. Eta Carinii, a ticking cosmic time bomb that's been defying stellar expectations for centuries. This isn't just any dying star, it's a luminous blue variable, one of the rarest and most unstable classes of hypergiants in the universe. Imagine a celestial pressure cooker with the mass of 100 suns, radiating the energy of 5 million, and barely holding itself together against its own outward fury. The fireworks began in earnest during the 1840s when Eta Carinii underwent the Great Eruption, not a typo, but a full-blown stellar tantrum that briefly made it the second brightest object in the night sky. For over a decade, this monster pumped out more light than an entire galaxy, ejecting enough material to form at least 10 Jupiters. The aftermath, a bizarre dumbbell-shaped nebula called the homunculus, twin lobes of gas expanding at nearly 2 million miles per hour, cradling the star like glowing hands restraining a prisoner. What caused this outburst remains one of astrophysics' greatest puzzles. Most stars die in a single, catastrophic supernova. Eta Carinii opted for a slow-motion explosion, a centuries-long striptease of its own destruction. Modern observations reveal even stranger behavior. The star isn't alone. It's locked in a gravitational dance with a smaller, hotter companion that whips around it every 5.5 years in an orbit so tight, their outer atmospheres nearly touch. Each close pass triggers new eruptions, with the smaller star essentially power washing Eta Carinii's surface, stripping away layers in cosmic sandblasts. X-ray telescopes catch these encounters in real time. The system's brightness in high-energy radiation spikes 1,000-fold as the star's stellar winds collide, creating shockwaves hot enough to vaporize planets. Yet the most unnerving detail is what's coming next. Eta Carinii is balanced on the knife edge of stability. Some models suggest it could implode into a black hole tomorrow or continue its erratic performance for another 100,000 years. When it finally does go supernova, the spectacle will outshine the full moon, visible even in daylight. Some theories propose it might skip the supernova stage entirely and collapse directly into a black hole without the usual fireworks, vanishing from the sky like a snuffed candle. For now, Eta Carinii serves as a laboratory for extreme physics, challenging our notions of how massive stars live and die. Its eruptions rewrite the rulebook on stellar behavior, proving that when it comes to cosmic violence, sometimes the slow burn is far more fascinating than the bang. Most galaxies glitter with stars, their spiral arms or elliptical halves glowing with billions of suns. But in the constellation Coma Berenices, a cosmic phantom lurks. Dragonfly 44, a galaxy so faint, so ghostly, it was only discovered in 2015 because it barely emits any light at all. Here's the twist: despite its near invisibility, this galaxy weighs as much as the Milky Way. The reason? It's stuffed with something we can't see, an unfathomable amount of dark matter, the universe's most perplexing ingredient. Dragonfly 44 isn't just unusual, it's an outright contradiction. Peering at it through the Keck and Gemini telescopes, astronomers counted a meager scatter of stars, about 1% the number in our galaxy. Yet its gravitational pull betrayed something colossal lurking beneath the surface. Stars at its outskirts whirled around the center at dizzying speeds, far too fast for the galaxy's visible mass to hold them in orbit, the only explanation. An invisible scaffold of dark matter, outnumbering normal matter by a staggering 10,000 to 1. Imagine a city where for every single building, there are 10,000 unseen foundations beneath structures so massive they dictate the skyline, yet completely invisible to the eye. That's Dragonfly 44, a galaxy where darkness is the architecture. What makes this dark galaxy even stranger is how it survived at all. The Coma cluster, where Dragonfly 44 resides, is a cosmic demolition derby, a crowded region where galaxies routinely smash together, stripping their neighbors of gas and stars. Yet somehow, this wispy ghost avoided disintegration, its dark matter halo acting like an invisible shield. Simulations suggest it might be a failed galaxy, one that formed with barely enough gas to birth stars, leaving its dark matter skeleton exposed. Or perhaps it was once a thriving system, violently stripped down by collisions until only its dark essence remained. Either way, it's a fossil of the universe's hidden scaffolding, a clue to how dark matter shapes galaxies in ways we're only beginning to grasp. Then there's the haunting question: are there more of these phantoms? Dragonfly 44 might not be alone. Surveys have since spotted other ultra-diffuse galaxies with similar star-starved profiles, hinting at a hidden population of dark matter-dominated oddities. Some researchers speculate these could be the universe's missing dark matter clumps, structures predicted by theory but never observed until now. If true, they could solve one of cosmology's biggest puzzles, the missing satellites problem, where simulations of dark matter predict thousands of small galaxies around giants like the Milky Way, yet we've only found a fraction of them. Perhaps they've been hiding in plain sight all along, masquerading as near-empty voids. The discovery of Dragonfly 44 forces us to rethink what a galaxy even is. For centuries, we defined them by their stars, but here's one that barely has any, yet rivals the Milky Way in sheer mass. It's a reminder that the universe's true framework is written in shadows, its most powerful forces utterly invisible. And as telescopes grow sharper, who knows how many more of these dark giants will find silent, ghostly, and rewriting the rules of cosmic structure one discovery at a time. The universe is vast beyond comprehension, filled with billions of galaxies, each containing billions of stars, so where is everybody? This is the Fermi paradox, the glaring contradiction between the high probability of alien civilizations and our complete lack of evidence for them. But the paradox runs deeper than silence. If advanced civilizations exist, why haven't we found traces of their engineering cosmic behemoths like Dyson spheres, interstellar highways, or planet-sized megastructures? After all, we've scoured the skies for anomalies, from Tabby's star's eerie dimming to the unexplained precision of odd radio circles. Yet the harder we look, the more the universe seems empty. Consider the numbers. The Milky Way alone houses over 100 billion stars, many older than our sun by billions of years. That's more than enough time for civilizations to arise, expand, and reshape the galaxy. Even at modest growth rates, a single spacefaring species could colonize the entire Milky Way in just a few million years, a blink in cosmic time. So why do our telescopes see no star-encircling swarms, no galaxy-spanning beacons? The answer might lie in the very objects we've been searching for. Take Tabby's star, once a prime candidate for alien megastructures. Its irregular dimming sparked theories of a partially built Dyson sphere, a colossal energy harvesting array. Yet follow-up studies suggested humbler explanations: dust clouds, cometary debris. This pattern repeats across astronomy. What looks like alien engineering often resolves into natural, if bizarre, phenomena. The universe is full of cosmic pranksters, objects that mimic artificiality without intent. Hoag's object's perfect ring, the red rectangle's geometric glow, all stunning, all natural. But what if we're not seeing megastructures because we're looking for the wrong things? Human imagination is limited by our own technological infancy. Advanced civilizations might harness physics we haven't discovered, building with dark matter, manipulating space-time itself. Their signatures could be hidden in gravitational waves, neutrino emissions, or even quantum fluctuations, channels we're only beginning to probe. Or perhaps they've transcended physical construction altogether, uploading into digital realms or higher dimensions, leaving no trace in the universe we perceive. Then there's the chilling possibility that civilizations inevitably self-destruct. Nuclear war, ecological collapse, runaway AI. Any could act as a great filter, wiping out intelligent life before it reaches interstellar scales. If true, the silence isn't just absence, it's a warning. The galaxies may be littered with the ruins of civilizations that never made it far enough to build megastructures, their echoes too faint for our instruments to catch. Yet absence of evidence isn't evidence of absence. Our search has barely begun. New telescopes like JWST and the upcoming Vera Rubin Observatory will scan millions of stars for anomalies, while projects like Breakthrough listen comb radio frequencies with unprecedented sensitivity. Even if the universe seems empty now, the next oddity, the next Tabby star or Oumuamua, might finally crack the paradox open. Until then, the silence isn't just a mystery, it's an invitation to keep looking, to stay curious, and to remember that in a cosmos this vast, the strangest discoveries may still lie ahead. From diamond planets to zombie stars, rogue galaxies to black holes playing hide and seek, we've journeyed through 25 of the cosmos' most baffling wonders, each one rewriting the rules of reality as we know it. These aren't just oddities, they're cosmic rebellion, nature's way of reminding us that the universe thrives on the unexpected. Every time we think we've got it figured out, space throws another curveball, a pulsar that shouldn't spin so fast, a void where galaxies should be, a star that refuses to die. These mysteries aren't flaws in our understanding, they're invitations to dig deeper, to question harder, to stay hungry for the next revelation. Think about what we've uncovered. The Great Attractor yanking entire galaxies toward the unknown. The Fermi Bubbles towering monuments to a black hole's tantrum. Oumuamua, the interstellar interloper that left us debating alien technology. These objects don't just defy textbooks, they demand new ones. They prove that the most profound discoveries often begin with a simple question: what is that? Behind every enigma, there's a scientist scratching their head, a telescope straining to see farther, a theory bending until it breaks. That's the thrill of exploration, the moment you realize the universe is stranger, wilder, and more inventive than even our boldest imaginations. But here's the best part: we've only scratched the surface. For every cosmic oddity we've named, there are countless more lurking in the shadows, waiting to be found. Maybe it's a planet with rings 1,000 times wider than Saturn's. Maybe it's a star older than time itself, or a black hole spinning so fast it warps reality into knots. The next great mystery could be hiding in data we've already collected, or it might be floating just beyond the edge of our vision, biding its time, so stay curious. The universe isn't done surprising us, and neither are we. Hit subscribe to join the hunt for the next cosmic head-scratcher, because the deeper we look, the weirder it gets. And who knows, the next time you glance up at the night sky, remember, somewhere out there, something impossible is waiting. We just haven't found it yet.